And we're live with Angular Air. Hello, everybody. My name is Kenzie Dodds. I am your host for Angular Air, this Angular broadcast podcast. And we are joined today by some guests who know a thing or two about TypeScript and using TypeScript with Angular, and that is our subject for the day. So, by way of introduction, first, our guests are Jonathan Turner and Mohammed. I didn't even practice your name. What is your last name?
Higazi.
Higazi. Okay. So these guys are on the TypeScript team, and they're going to share us some awesome stuff today. So, and then we have our panelists, Amy Knight.
Hello.
And Olivia Combe.
Hi.
And Kara Erickson.
Hello.
And we're joined by a new panelist, Jeff Welpley.
Hey, how's it going?
So Jeff was on the show a couple weeks ago. That was one of my favorite shows. It was about Angular 2 Alpha, and we had a great time. Such a great time that I wanted Jeff on the show every single week. So yeah, it's gonna be.
Thanks for letting me join, Ken.
Yeah, it's good. All right, and so let's go through a couple quick announcements before we start. So next week's show, same time, same place, just next week on June 16th, and it is Angular's new router with Brian Ford, and Amy is being so kind to help get that all set up, and that's going to be a great episode. We're excited about that. And next announcement, stickers. So if you haven't been seeing on Twitter, I am super stoked about the Angular Air stickers. So go check those out on Sticker Mule. The link is in the Hangout comments, so go check that out. And then, as always, follow us on Google+ or Twitter to keep up to date with the shows that are coming up. So let's go ahead and get started. First, I think it would be prudent for us to know who our guests are. So if you guys could just each introduce yourselves and what your role is in TypeScript, and then we can get into talking about what TypeScript is.
Sure, I'll go first. So I'm Jonathan Turner. I'm the program manager for the TypeScript team. Program manager is kind of like, I think I call it the inglorious cat herder. Most of what I do is try to focus what I can of the engineering efforts and energy in a direction, and make sure I can get all the obstacles out of the way so we can go as fast as we can. A lot of times I'm working with external partners, so working with people like the Angular team, to make sure that I've got a clear sense of everything that they need. Yeah, that's me.
Yeah, I'm Mohammed Higazi. I'm the engineering manager for TypeScript, the TypeScript compiler team. So basically, we take care of building the compiler, taking care of the core language service, and so on and so forth.
Great. I'm actually quite curious what it takes to build a compiler, and that maybe some people aren't as interested in that. I don't know if I'd want to build a compiler, but I'm impressed by it. So I'd be curious to get a high-level overview of how that works. But before we get too deep into that, I think some people may be watching the show who don't know what TypeScript is and why it matters in the context of Angular. So why don't we kick off with that?
Sure. So TypeScript, you can think of it like a thin layer on top of just plain JavaScript. So we're adding a couple of additional features to JavaScript to make it easier to work with, to make it easier to scale up to larger projects, to work in an editor and get nice IntelliSense and nice error checking. So I guess one way to think is take that vanilla JavaScript, and now that ES6 has been ratified, it's kind of like all those nice classes and modules and lambdas and all of that kind of make up ES6. On top of that, add a type system. That's totally optional. You can kind of just sprinkle in types. And as you do that, the compiler can help check for those errors and can give you like really good auto-completion. We've also started working on adding ES7 style features. So async await is upcoming, and the decorators that Angular 2 uses are part of what TypeScript provides now. So TypeScript compiles all that away, so you get a nice clean ES5 output. So that runs across any browser, runs on Node, and whatnot. So it's kind of part type checker and part transpiler.
And tools.
And tools, yeah. So yeah, that's true. So not just the compiler, but we do a whole bunch of tooling in addition to that. So we do the Visual Studio tooling. So all of the kind of as you're typing code and it's checking behind the scenes and giving those errors, it's kind of like a flywheel approach. So we make the tools that can do that. And we also do Visual Studio Code, the kind of the language service that it uses, which you may be familiar with. We did a Sublime plugin. Same thing. All these are built on the same code base, but we're making them work with a variety of editors and IDEs.
So do you work with WebStorm as well, or is that just
We know the WebStorm folks, and we've got a developer here that kind of talks to them over email, answers questions and whatnot. And they may at some point start to use more of our code. They currently have their own engine that they pieced together so it works with the TypeScript code bases. But they may eventually kind of move because we're trying to standardize to like one analysis engine that everyone can kind of use.
Cool. So with TypeScript, like obviously there's like if I decide that I want to take my vanilla ES5 code and I want to start using TypeScript, what about TypeScript makes it worth including this build step in my development process?
Yeah, I guess if all you use is the command line compiler, what you can get is that bit of error checking. So I can catch, or the compiler can catch things that would be, relatively simple once you saw the bug, but you may not catch it until runtime. You may think you have a lot of unit tests that cover all your code, but that type checker gives you that extra bit of confidence that you've written code and the code's correct before you ship it out. So that compile step, if you already have a compile step in your pipeline for doing things like minification, adding the TypeScript compiler is a pretty straightforward piece to kind of extending that pipeline, and then you get that kind of extra confidence as part of that.
Yeah, I think if you viewers or listeners, if you're not using a build to build your project, it's time that you start. It's kind of crazy to not be doing that right now. Yeah, because there are just so many things. Even if you're not using TypeScript, but you use Babel or something, you're missing out big time. So one other question I had about TypeScript in general before we get into Angular or anything. What about runtime checking? Can TypeScript give me any safety at runtime, or is it just at compile time?
That's a great question. I mean, the kind of the philosophy of TypeScript is that TypeScript is all about that build time, or when you're editing in the editor, it tries to get out of your way after you've compiled. So we don't put anything in the output that would make it kind of dirty or whatnot. So it should just be very clean JavaScript on the output. So that's good and bad, right? So kind of to your point, you don't have that runtime assertion of a type. But the good side is that you look at the code and that's exactly what you would have written if you didn't have TypeScript at all, you just wrote it by hand. So you kind of have that confidence that what's coming out is really clean.
So that's kind of like what Babel does, right?
Yeah, it tries to be pretty clean too. That's right.
Okay.
Maybe you can touch on that a little bit. How does the compiler work? Maybe more specifically, how are you able to take ES6 code and turn it into human readable ES5 code?
So without going into the details of the compiler architecture, but it is more or less your kind of normal compiler class in junior class, junior year in college. You have a parser, scanner, and a type checker. And what we do is the basic assumption is that ES6 is TypeScript is a superset of JavaScript. So JavaScript, by JavaScript I mean ECMAScript, any ratified JavaScript kind of standard. So you take JavaScript, it's a valid TypeScript, just copy your JavaScript, paste it in a TypeScript file and run the compiler on it. It's a valid syntax. The only thing that we add on top is types. and in addition to some additional kind of syntactic sugars. So the compiler is just a normal JavaScript parser. We parse these, we parse the types, we do our normal kind of syntactic validation, make sure that you didn't miss parentheses or anything like that, and so on and so forth. And then this is where the type checker comes in place. The type checker is basically trying to infer types as much as it can and understand the type annotations that you have put in place. It does all the checking between, like, if you said that a variable is a string, it makes sure that you never assign a number to it. If you have a function that is declared that would accept an object that's a property bag, you cannot give it another function, for example, and so on and so forth. Once the type checker is done with its work, which is basically generating errors, at that point, the type checker, the only purpose that the type checker is there is to give you warnings, to tell you that you did something that was not intended per se. Once it is done with its work, we go back to the normal kind of transpiler mode, which is like we have an ASD in memory, we have a tree of your JavaScript, input JavaScript, and we do a simple transformation, a text-to-text transformation process where we rewrite it into, depending on what we're doing. So there are different transformations. So one of them is, as Jonathan mentioned, like bringing you ES6 today without having to have the support in the engines. So one of them is rewriting classes, rewriting string templates as normal strings, rewriting destructuring patterns as normal assignments, and so on and so forth. And there's another one which is module transformations. So we will compile down your ES6 modules into either CommonJS or AMD, like normal AMD or UMD or system.js support, and so on and so forth. And these involve transformations of what it means to how exports are wired, and so on and so forth. Back to the cleanliness of the output, we've tried from the beginning is just to keep it idiomatic as possible. Is try to write, like, for example, our class pattern is what you would write if you were to write like prototype inheritance chain using functions, basically. So if you had enough time, you had all the resources, and you tried to play with it for a bit, and you reached the right kind of like the simplest syntax where you can do that. And I think just looking at JavaScript, it will be hard to know that it was auto-generated as kind of part of what we try to do. And we go into kind of a lot of pain to make sure that the emitted code is just like your input code. We try to maintain order. We try not to change the order of statements. We try to keep we do not try to inject any logic. Anything that you've written will get on the other side, and so on and so forth. And anything that is not expected, especially when it comes to performance, we try not to. So, for example, if you're using accessors like getters and setters, we will tell you that we cannot do it in a good way in ES3, and we will let you decide what you want to do.
Yep. Some of the patterns that we output, like for example, the classes to the kind of the function closure pattern, that was informed by one of the guys that helped create the JavaScript engine for Internet Explorer and for Edge. So he was kind of looking over our shoulders, looking at the emitted JavaScript, saying, "Oh, you want to tweak the pattern that you're emitting so that it's this style of pattern. And when you do that, you're going to get a lot better performance in the VMs." So we did that on the TypeScript compiler, and then the Google team, the V8 team, took our output and started optimizing for it as well. So you can kind of use that same output pattern, and if you're writing in TypeScript, you get that nice clean performance.
And the idea is you start with JS, you end with JS. Like your code, it's JavaScript, TypeScript is JavaScript. You write your code, and if you know JavaScript, you know TypeScript. You write your code. We give you the option to write additional type information that will enforce some rules at design time, but they evaporate once we're done, and you're left with your code. And as we always say, like if you really at some point you do not like TypeScript, take your JavaScript output that is generated and go on.
So I was listening to another podcast yesterday with Amy on JS Jabber, and it was about ESInt, and they said that they were using Esprima as a parser. Are you using this as well, or another one?
No,
maybe.
We're using. So we have a different parser. It's a lot similar. Just the handwritten recursive ascent parser, your typical parser. The difference is that when we started, we couldn't use Esprima. One of the main reasons is because we have tooling. Like we like part of the what we try to support is a core compiler, a core transpiler, and a type checker. In addition to supporting tooling like language service in IDEs and headers and stuff like that. One of the scenarios that we really care about is quick turnaround when you're doing like these operations in the editor where you're editing most of the time. So we usually we always want to do something like sub 10 milliseconds for these requests, and to do that efficiently we need to do incremental parsing. Sprima didn't support incremental parsing. The tree is kind of bigger than our tree, which is another problem. If you're working with IDEs, you're keeping a lot of stuff in memory, so you have to kind of be cognizant of your footprint.
We're really one of the claims for TypeScript is that it helps you with the larger scale applications. So as you can imagine, you're scaling up applications to 100,000 or hundreds of thousands of lines of code. Making sure that the editing experience is very snappy requires shaving off every little bit of memory you can.
Yep. So our tree and our parser, we've gone through like different iterations of making sure that it is kind of as fast as we can and as light as we can. Having said so, we like a couple of days ago we were looking at like a new fork of Sprima, or that will be more like they're going with a concrete ESD. So maybe that will be like a concrete ESD. Obviously, will be easier to implement incremental parsing on top. So maybe that will be something that we'll be following and looking into it. You wouldn't want to maintain a parser unless you have to.
Yep, that's a lot of work.
One thing that I need to mention just as a tangent really quick is I forgot to mention at the beginning of the show that we do have Q&A. So for our viewers who are watching live, if you're watching on the Hangouts page, you can open up the Q&A app and ask questions that we'll answer at the end of our show. So the last like 10 or 15 minutes, we'll just go through some of your questions. And looks like nobody's asked any yet, so let's get on that, everybody. So yeah, so let's move on a little bit to Angular and how Angular and TypeScript are friends. Can you guys give us a little bit of a history on how TypeScript and Angular became buddies?
Sure. So I guess it kind of started last year. When Rob Eisenberg was helping out with the Angular 2 project. He had been kind of a fan of the TypeScript project for a while and had been kind of watching us grow as the Angular 2 stuff had been growing. Actually, even before that, I did have one conversation with Mishko. So we've, it's been like a couple of years in the making to get to this point, and we would kind of check in. But Rob, I think, was probably to credit for kind of that second push where like, oh, let's actually try this. It looks like the things that Angular 2 needs and the things that TypeScript can provide are getting closer and closer. So he helped kind of set up that first meeting. We chatted with them briefly and then found out that they were working on this thing called AtScript, which is, just like TypeScript is a superset of JavaScript, AtScript was ostensibly the superset of TypeScript. And so we said, well, let's come down and visit. So we, booked our plane tickets and we flew down. I took Mohammed and Anders down, and we talked to the Angular guys. And we're sitting around the table, kind of chatting out like our directions and where we wanted, the features to kind of grow and the tools to grow and the Angular to grow. And we're like, wait a second, we had this kind of like snap in our heads, like we're all engineers. We're kind of, when we came in the door, we were, this guy was from Google and this guy was from Microsoft, and it's like, well, we should never get along because that's what people tell us. But really, when we sat down and actually hashed out these problems, we're like, well, these are fun. Let's tackle these because these look like something that we could do, and it looked like a lot of people could really benefit from the solutions that we come up with. So that was around November of last year, and since then, I think we've tried to meet with them, once every couple of months to get their set of requirements, have them start to try out things that we are working on. So because of that effort and because of Rob and Yehuda Katz, who's also really kind of integral in some of how this stuff works, we started working on a proposal for decorators for ES7, and then we started implementing it, and Babel has since implemented it. So a lot of kind of those first fruits are starting to turn into standards efforts and tool efforts and whatnot. So once they saw kind of the direction that we were going, that's when around March, so like literally right before ngConf, they're like, no, this is good. Let's build Angular 2 on TypeScript because we like these guys. We think that direction is a good direction, and we can work together with these guys. So that's what we did. We kind of said, let's do it. So since then, they've, of course, they announced at ngConf they're building on TypeScript. They're getting rid of the AdScript, and not really getting rid of it, but the kind of the principles and philosophy of AdScript merged into TypeScript, so that the kinds of things they wanted to do, we would be able to do ourselves.
So what does it mean for tracer, since TypeScript has its own transpiler?
Right. So yeah, there's like a couple of transpilers. Tracer was one of the early ones. 6-to-5, which became Babel, was another one. I would say that these are all just trying to. If you don't look at like what TypeScript does with a type system, we're all transpilers. We're not trying to move and replace things. But if you're talking about specifically for Angular 2, I think they're moving all their tools onto TypeScript. So they won't be using Tracer as kind of the transpile tool. But in doing that step, they're also trying to open up to other transpilers. So they're talking with the Babel team so that Babel will be able to work just as easily with Angular 2.
So I'm curious, at some point after the Angular team and you guys agreed, okay, we're going to do this. At some point, two of my heroes, Anders Hellsberg and Mishko, got in a room to talk and really hash out the details of how they were going to actually, merge these two concepts. And it seems like, some things got in, like decorators, you guys obviously committed to, and some things didn't, like the runtime assertions. So can you give us a little bit of insight into kind of like the horse trading that went on between those two?
Yeah, I think it wasn't quite so shady. It really was. We were staring at a whiteboard. We're writing out, okay, these are the things that we can do easily. These are the things that start getting harder. And we're like, let's tackle them one by one. So we started tackling them. The decorators is something that we knew other libraries wanted. And Yehuda, who had been doing a lot of research already on decorators, was kind of ready to jump in and start doing standards efforts work, which is a lot of work. If any of you have ever done that, much respect. It's a lot of work to do that. So he had already been doing that kind of work. So we just kind of hitched to that wagon and said, let's all work together on that. So that process has been kind of ongoing. The runtime types, because TypeScript is one of the efforts for doing types, and there isn't like a standard type system for JavaScript yet. Hopefully, maybe in the coming years there will be. It doesn't make sense to kind of do standards effort work there. So what we've done is we've kind of made an experimental part of the compiler that will do some very rudimentary injection of types into the runtime. We don't really promote it per se because I think we're still trying to bake it. We're still trying to figure out how it will work. But you can get some of that basic reflection that AdScript allows you to do, and then use that. So, for example, Angular 2 does use that so that they can do dependency injection. They'll do a quick call to this experimental feature that will give them the types that they can then use to instantiate.
So actually, I was wondering about Angular 2's use of the type system and how that works with the injector. Can either one of you talk on that at all?
Who to talk about that?
So just as Jonathan mentioned, we have like an experimental flag that will allow you to capture some type information from design time and pass it and store it at runtime so that you can access it. So this is how decorators work, and this is what Angular 2 uses to do the dynamic injection. There are limitations, of course. We do not want to serialize the whole type system, just because it is a lot of data that most probably your program will not need all of that. slow it down, and so on and so forth.
One way to kind of think of it might be that the way it works now is it works with basic types and it works with constructor functions. We don't do anything outside of that. But the nice thing with a basic type or constructor function is now I have enough to go to an instantiation of using the constructor function, or I can do a wrapper that does a quick wrap of their function and checks the types as they come in.
Yeah, pretty much. And I mean, that's the basic of dynamic injection you want to do. You want to have a class, you want to instantiate an instance of it, but you want to kind of satisfy all its dependencies first before you create that object. So if you have enough information about what it needs, you can go instantiate them, walk the tree, figure out what you need to do, and then do your dynamic instantiation correctly. So we think that we have enough pieces in place to allow for the dynamic injection scenarios. We're still learning, so we'll see how that evolves, I guess, over time.
Yeah, and if anyone that's viewing is interested in how to help out here, I know I'm kind of doing my plug early, but this is a great place to do the plug because things like this, we're not setting them in stone. There's a lot of experimental features in TypeScript that we're just trying out. Any of the ES7 stuff is experimental. Any of this kind of not even ES7 yet. It's kind of like the inkle and the twinkle in the eye. Come jump on the GitHub and kind of help us out with it. As we design it, all the design is kind of in the open, so you can come and give your input at any part in the process.
Awesome. Kira, you had a pretty good question in here. Do you want to jump on?
Sure. I was just wondering if there are any, hot tips or gotchas that you would want to talk about for someone that's new to TypeScript.
Hot tips for gotchas for using TypeScript. Well, the first ones that come to mind for me are TypeScript will always prefer patterns that you can write an interface for. Right, so I can go ahead of time, I can think about what this object is going to look like, I plan ahead, I write the whole thing out. So anything that's fancy and dynamic, it starts to have some problems with. So expandos, mix-ins, extensions, all of the more dynamic, fun parts of JavaScript, you kind of have to plan ahead to support. It's not going to look at the code that you've written and guess from this kind of amalgam of lines and lines of code exactly what that thing is doing.
So are you telling me that TypeScript is taking the fun out of JavaScript? Just kidding.
So just to complete that, I mean, we're looking into supporting mix-ins. We've had few ideas. There were a lot of pieces that we need to build to reach that point, and I think we're almost there. So
yeah, I mean, we're a fan of the fun parts too, right? But I think the 1.0 or the 2.0 kind of TypeScript was let's type all of ES5, let's type all of ES6 if we can, and then now let's see how much of the more fun patterns we can start trying to tackle.
One of the gotchas or at least the problems that I have heard quite a lot lately, and it's not related to TypeScript per se, but it is about modules. ES6 has become the kind of spec of the line per se, so people are starting to dabble with modules, and you start to see there are some problems related to loaders and bundlers, and there isn't the tool chain hasn't been kind of complete yet. We're still experimenting. We're trying to kind of help as much as we can, and we're trying to integrate with other tools as much as we can, including things like system.js, like module loader, JSPM, and so on and so forth. And so there's some confusion around that area. So that's a place that we get a lot of questions.
Yeah. I would say too, anything that's ES7. So we mentioned decorators. Even though Angular 2 is built on decorators, decorators are still kind of in process to be standardized because the standard process is long and they tend to find little tweaks in the design that need to happen. Like building a giant code base on something that uses experimental features, just know what you're buying in for. You may have to do tweaks to your code as you go forward.
So actually, I'm curious with that because I know that Anders really believes in like backwards compatibility, and like that's like a strong tenet of everything. But if you're part of what you guys do is to implement these experimental features, doesn't that potentially introduce something where you have to introduce a baking change? Like potentially, you might not have done that already, but in the future that might happen, right?
Yeah, there's always that risk of, when we did the earlier versions of TypeScript, we aligned to a class syntax and an arrow function syntax and all these things that weren't in a ratified version of JavaScript and weren't going to be in a ratified version of JavaScript for 3 years. Each one of those was kind of a risk to build TypeScript on top of. So there is kind of a calculated risk part to it. As if we start incorporating ES7 features before that's been ratified. So there's a couple of things that kind of help us out. One, the long time for ratification is hopefully at an end. So now with TC39, the kind of the standards body for JavaScript, the standard is supposed to evolve once every year instead of once every 5 years or every 10 years. So that quick turnaround time should help us catch things earlier. And if things aren't ready, they'll kind of lag out of the version. And kind of the other piece that helps with that is that we're adding a set of kind of like an experimental flag. And without the experimental flag, you can't even use these features. So you're looking at your code and you're like, aha, okay, I am starting to use things that are experimental. I do need to be aware that these things may change. They may change, if they change in like a subtle way, we'll try to like help you out or whatnot. We'll try to give you tooling to help that transition. But you as a developer need to know, okay, yeah, I'm taking a bet on something that is maybe moving ground.
And we've tried to be cautious about what features we tackle. Like, for example, we do not introduce expression-level operators. And people usually complain about that. But we try not to kind of be in a place where ES6 or the TC39 would be considering at some point in the future. Yep. So we would like to create conflicts.
Right.
We're committed to trailing the committee, though.
I would say it's not set in stone because we do want to be able to kind of experiment. But I would say that the way to think about our philosophy is that we will only extend the syntax with things that we are actively trying to standardize or literally are on an experimental flag or something. So we want to get out of the way of TC39. And in any way that JavaScript could evolve, we want it to just healthily kind of evolve and TypeScript to evolve with it.
I had a...
Sorry, Amy, go ahead.
I was just kind of following along in our doc, and I had a question. This is like a popular question I had on our ES6 episode. So the stuff, I haven't really written TypeScript yet, so but I kind of hear as I look at code samples and read that like everyone really talks about it being object-oriented. So as far as like writing Angular, this was a popular question for me. Like, what portions of Angular do I want to do in an object-oriented way with classes, and what part do I want to keep functional? So with TypeScript, do you think it's the same thing as with ES6, or like what patterns do you guys recommend and see as far as like writing your code in Angular functionally and then with classes?
Well, a funny thing is that the TypeScript compiler is totally written in a functional pattern. So if you go to TypeScript on GitHub and you look at the sources, you will probably in the core compiler you will not find a single class. It's all functions and are passing objects around, and it's your typical JavaScript application.
And it kind of uses interfaces and object types to say what the contract is between these functions, but it's all functions and closures.
Yep. So basically, if you look at ASDs, there's a bunch of interfaces, and interfaces are types in general, just information for the compiler at the same time, and they just go away. So you're left with an object structure that represents your nodes and your ASD, and the interfaces tells the compiler which node is which, basically. So that's for functional programming. Of course, classes are a big part of ES6 and a big part of what TypeScript started with from the beginning. So classes are supported. So the question is, which pattern do you choose? That's gonna...
Yeah, and classes too, I think. For Angular 2, especially, the Angular 2, a lot of the kind of nice ergonomics that it has are around, I have a class, and I decorate the class, and now I can fully separate all its configuration pieces from kind of the internal logic pieces. So you'll probably mix and match, I assume, rather than trying to stick to one and go all the way through in that one style.
Yeah, and part of the thing that we tried to do from the beginning is, for example, the type system on TypeScript is structural. So there isn't really special kind of nature to classes or interfaces. They can mix and match. So if you have an object that is implemented as a class, you can really implement the same structure using a function, and you will get, they're assignable, the compiler will not get into your way. So if part of your code is written in a class structure, the other part is written in a functional structure, compiler will still help you. But again, that's more of an ideological question.
Yeah, it's totally up to you.
You mentioned earlier that the Chakra engine was, or the guy who was working on the Chakra engine helped you with some of the output from TypeScript to optimize it. So was that just for classes, or was that for like any TypeScript that was modified? So in other words, is there a benefit to using classes from a performance standpoint because of the output, or does it not matter?
As long as you're using like good patterns yourself in your code, the compiler is basically doing that part for you. So you don't have to remember exactly the nice patterns. So there is kind of a slight performance benefit to using the class patterns in TypeScript. But that said, if you use the same, you write that by hand, you'll get that.
Yeah, I mean, at the end, you're talking about engines and their optimizations. And different engines handle, like Chakra and V8 are differ on what optimizations they do for functions and classes, and hoisted or like internal functions, as well as like accessing properties that are not defined, and so on and so forth. And then that is the part of the fun part about JavaScript, is that you have to know what you're doing basically at that point. But if you're using the TypeScript classes, that's what basically Jonathan was saying, is that so we'll try to give you an idiomatic pattern that is well kind of tested in the has well tested performance characteristics.
So I was curious in one other thing that you mentioned earlier. We talked about how the Google team, and it was obvious that to move to TypeScript from AtScript. I'm sure that you've had some similar conversations with Facebook over their use of, like, they have the Flow library that they use that does some type inference. So was it different, I guess, where they seem to like kind of stick to their direction and not kind of join forces?
No, I think that's a good question, and we did talk with them a few times. When they first reached out to us, they wanted us to put in JSX support into TypeScript. At the time, JSX seemed like, yeah, we could put that in under a flag. Send us a pull request if you guys start on it first. And I think when they started looking at what they needed for their set of tooling, and you would have to kind of interview the Facebook guys for the full story, but just kind of my take from my point of view, it seemed like they have an infrastructure inside of Facebook that plugs these certain types of tools like that plug together. So for example, they have a PHP thing called Hack, and it's a server that does all this kind of testing of all their PHP code. And so they wanted something similar for all their JavaScript code. So they kind of took a lot of the same logic and moved it into testing JavaScript instead of PHP, and made Flow. We talk with the Flow guys, like I talk with the Flow guys pretty regularly about ways that we can kind of standardize. It sounds like they have more experiments that they want to do rather than kind of locking into TypeScript. They want to kind of take Flow and kind of keep evolving it in the direction that makes sense for Facebook. That said, we maybe a good time to chime in about some of the stuff that we're doing. So I know this is the Angular podcast, but I know some of you may also be doing React programming. We are adding a lot of React support to TypeScript in the upcoming version. So you'll be able to turn on a JSX mode, and then when you do that, you'll be able to have kind of full type checking through all your JSX code and your classes. So you've got like a good React experience as well as a good Angular experience.
Yeah, I saw that was like the second most commented thing on GitHub, right up to like up against non-null parameters or whatever, something like that. Cool.
So
Yep,
I think
so-
we're winding down on our time, but I think we still had a question or two that some panelists wanted to ask.
Yep. So Microsoft doesn't get any revenue from TypeScript. So how do you justify the investment that you're doing in this open source project?
Yeah. So TypeScript serves a couple of roles. When it was first created, it was created as a tool that teams inside of Microsoft would use to build large applications. So teams from Office and from Windows were coming to the developer division where we work, and we're saying, like, how do we write large JavaScript applications, not just with one person, but like, you know, multiple teams coordinating effort. So TypeScript was kind of born out of that. So we have dozens of teams internally that use TypeScript to build these large applications. Because we help support that, that kind of gives us kind of incentive to continue to grow inside of Microsoft, because we help other people make lots of money. There's also just a lot of energy in Microsoft around open source right now. So we are, you know, one of the earlier projects to embrace open source, and now a lot of kind of the language efforts and developer division efforts are becoming open source. And there's just a lot of excitement around that, and building good tooling that kind of works with good standards, works with libraries, and works with kind of the community as a whole.
Yep, I really like the direction that Microsoft is heading these last years. If you can just ask the Edge team to rename the browser to Spartan, because I really love this name.
Nice. Yeah, +1 for me. I like that better than Edge. All right. Okay, so I think unless anybody has any other questions that they wanted to ask, I think we can go into the Q&A. We got quite a few good ones. Okay, we'll just jump in then. So the top one that I'm going to pick is from Mike Hardington, and his question is, how could you take an ES5-based library and use TypeScript to get static typing?
Great. So there's an effort going on that we didn't actually start. It was just a couple people in the JavaScript community. They started documenting the kind of the type information for just plain old JavaScript libraries. So at the time we had put out a jQuery, one of these what we call DTS files or typings files. And all you have to do is take that, drop it in your project, and then TypeScript will see that file, and then we'll let you kind of get full type information, full IntelliSense against the library without changing the library. So that file kind of gives all that information. So they kind of started documenting library after library. It's now like over 900 or almost 1,000. The site is called Definitely Typed, and there's dozens of people that started it, and now it's gone to hundreds and hundreds of contributors. So if you're using a kind of a standard or even an obscure JavaScript library, you can probably find it in Definitely Typed now. If you write your own, we have a handbook on the website that teaches you how to write a DTS file for your own projects, for your own libraries. So you can still keep the JavaScript the same and not have to move everything to TypeScript. And use these DTS files to give you that same experience.
Oh, that's good to know, because I saw someone type one of my leaves and I was wondering what it was. So now I know.
You might want to check it out,
Yep.
Cool. All right, so next question from Andre Bucati, I think. He says, will we finally see a solution for the nasty this issue?
So I'm kind of working on that off to the side and kind of floating that every few design meetings or so. There are more and more places where this is cropping up, and I think that being able to describe what the type of this is and the type system in a really flexible way has a lot of advantages. That said, I think short term we're focused on getting 2.0. 2.0 is where we say ES6 is done. We're supporting all the major features of ES6, and that's our main focus right now for the next couple of months. When ES6, all those main features are done, then we'll probably start looking at ways we can make the type system stronger, the tooling system, like the integration to a bunch of tools. We'll try to integrate with a bunch more tools than we have in the past, so you can kind of use this in more places.
Great. Okay, next question from Chris Knutson, I think is how you say that name. Will we see native support for TypeScript in upcoming versions of Edge or Chrome?
When you see native support, the current plan is still that TypeScript will be a JavaScript. It's all about JavaScript, really. Like, you're compiling to JavaScript, you run that. We compile down to that efficient JavaScript, hopefully, efficient JavaScript patterns, and you can run that. Excuse me. So there's no real plan to go any further than that in terms of like sticking that directly in the browsers. I mentioned before that we're working on a typing effort so that you can have a typed JavaScript, and we hope that that kind of picks up steam as, for example, the Google or the Facebook Flow team, they mature their Flow product and they're ready to contribute to standards effort. We kind of fully encourage that, and we can work together with other vendors like the Clojure compiler team at Google that have been working on similar things.
Cool. Sounds good. Next question from Hughes Stefanski, I think. Can you talk about Angular 1 experience with TypeScript?
Sure. You want to go do that, or?
Sure. So Angular 1 experience, we're currently working on like a few samples, just to make sure that it's easy for somebody who's looking for writing a TypeScript application with Angular 1 to find that as well. I think there has been so Angular 1 and TypeScript have been around for a while, and there are already applications that are written using both tools, and there's patterns that have kind of evolved to how to write your kind of Angular 1 controllers and so on and so forth. And we just need to put them and document them so that people can find them if you're starting on a new app or you want to adopt TypeScript or something like that. So we're working on that. Hopefully in the few next weeks we have something that we can point people to.
Great. I know that there are members in the community who preach the TypeScript gospel with Angular, so it's definitely possible, and many recommend it. So, cool. Another question from Hugh Stefanski. He says, is there a plan to debug TypeScript directly within Visual Studio Code?
In Visual Studio Code, yeah, actually, I think with the most recent release, which is 0.3.0, they did turn on debugging TypeScript code directly in Visual Studio Code. If it's not in that one, then it's coming soon.
Cool, good to hear. I'm sure Hughes will be excited about that. So next question, is it possible to create dependency injection based on interfaces using TypeScript? I think the simple answer to that is yes, because that's what Angular 2 is doing, right?
On classes, yes. That was kind of the caveat with the type runtime types. Interfaces don't have a runtime type, like a constructor function that we can just hand the decorator. So what you're going to get is just something that says object. And that's kind of, if we keep evolving the runtime types, we want to be able to express things, but as Mohammed says, it's not trivial, and it actually gets really complicated pretty quickly. Imagine an interface that's recursive, right? So how do you describe that in a really generic way? Or a generic function, or generic, whatever. So these things we may continue to explore, or we may just say, the set of functionality that we have now is probably going to, be the set for a little while. But I think that that's one of those things that we want the community to kind of come on to GitHub and to chat with us as we're kind of exploring these features.
Yeah, and in addition to types in TypeScript are structural, so it's a bit it's not trivial to do some dynamic injection using structural types, because you have to go figure out if the structures are compatible at runtime, and that's not cheap.
You're working on hard problems, and we appreciate it. Cool. So another question by Sandra Mack. I think that's how you say his name. What are the or what benefits do TypeScript offer over using an ES6 transpiler besides the type system?
Besides the type system, so if it's just an ES6 transpiler, what you get is a set of experimental ES7 features. So Babel has started doing this as well. So we're not the only ones that do this. But being able to, for example, in 1.6, which is the one after the one we're working on right now, you'll be able to do async await. So promise level programming, you'll have an async await implementation that you can use. Decorators, for example, are another feature. So it's not just the type system, but the type system does kind of plug into these experimental features to give you a bonus on top.
And one other thing is to remember tooling as well.
That's true.
Yeah, so I mean, that's basically if one of the reasons of the existence of the optional type system is to enable these scenarios, to allow you to do refactoring, safe refactorings. If you want to rename something everywhere, you can do that. Allow you to do like split your projects into split your code into projects and allow them to interface safely with each other, have different groups of developers working on different pieces of that code without having to worry about like breaking the world. And again, like development, the whole idea here is to increasing developer productivity, whether it is tooling or catching errors as soon as possible, or providing patterns that you would have to rewrite over and over every time that the compiler can abstract out for you.
Cool. I think the type system is a huge benefit. People don't appreciate that as much as they could. Okay, and last question. I think this is a great one. How do you trace bugs from the transpiled JavaScript back to the TypeScript equivalent?
So we have a flag on the compiler that will output a source map file. And source maps are supported in all modern browsers, and they're supported in Visual Studio and hopefully soon Visual Studio Code. And that source map file will map from the output JavaScript back to the original TypeScript. And you can kind of see this if you compile with that flag, you open it in something like Google Chrome and go into the developer tools. It'll show you the TypeScript file, and you can kind of step through the TypeScript file instead of stepping through that JavaScript file.
Neato. Cool. Highly recommend source maps if you're not using it, especially if you're minifying your code and shipping it off to production. Please send it with source maps so that you can debug sanely. Cool. Okay, so that's our last question. So we're going to move on into picks. And so just as a reminder, picks are like anything that you care to pick. It doesn't have to be tech related or not. But whatever you do pick or whatever tips you give, please post it in the comments of the Hangout so that people can go see what they are later. And I just posted a link to the Hangout there. So let's go ahead and get started. Let's start with Amy. What picks do you have for us and tips?
Sure. So I have another pick, or another podcast rather. This one's really good. It's called Software Engineering Radio. And rather than like getting into, I think, some of like the newer technologies that are out there, they get into some more like core concepts. But I get a lot out of listening to this one, so I would recommend everyone go listen to it. And that's it for me.
Great, thanks. Olivia.
Yep. So I have two. The first one is a conference that I'm attending next week. It's named Go to Amsterdam, and you will be able to see me. I will have Angular stickers if I can get them in time, and there will be Pascal and Carmen as well doing another talk. So if you want to come, I post the link. You can still buy tickets, and I can give you a discount for the ticket. So use it. And my other pick is not tech related. It's about the last two episodes of Game of Thrones. If you haven't seen them, maybe if you watch the podcast, I have an awesome Game of Thrones t-shirt tonight. Because in the last two episodes, so I'm going to spoil here, and you have
I haven't watched the last one.
I think he just got muted.
He just muted himself. I think he did it on purpose. He's super excited though.
Yeah, and that's why you need to see them.
So if you are listening to this and aren't watching, I would highly. This is my pick. I want you to watch Olivia just go crazy just right there. That was funny. Thanks, Olivia.
You're welcome.
Jeff, do you have any picks for us and tips?
Yeah, sure. For 2 picks. First, Angular U. We're 2 weeks out from talk that Patrick and I are giving on server rendering, Angular 2 server rendering. So watch that online. If you're in San Francisco area, try to make it over there. And then the other pick is this past episode of Adventures in Angular podcast. My friend Gleb Bamatov was on, and I thought did a great job talking about Angular performance in Angular 1. So I would highly recommend that. I apologize, Ken, that he wasn't able to solve your problem, but I think he did a pretty good job otherwise.
I definitely +1 to that pick, and he is planning on actually doing a screencast of helping to improve performance for my problem with making Angular formally even better. So let's see. Hopefully we can put enough pressure on him that he does that. That'll be awesome. Cool. I guess I'm talking, so I'll go ahead. So TypeScript is awesome because it gives you type checking at compile time. And one of the things that I really like about React, and something that they totally got right, was prop types. And so that's runtime checking for when you're using a component. They can say, hey, this is my user avatar component, and I require a user that has an image property or something. And so you can declaratively say what you require to use this component, and then you get warnings in the console when you're using it wrong. And so this is at runtime. So I liked that concept so much that I wanted it in Angular. And so I wrote a library. It has 0 dependencies. It's called API check. And it's very similar to the API of React prop types, but it has no dependencies, and so you can use it. And I actually use it in Angular formally. And when I implemented it, I got a lot fewer questions about how to use things properly. And I'm sure the TypeScript guys totally get that. Because yeah, it's just so much nicer when the tool teaches people how to use the tool. So I also, on top of that, once I finished with API check, I built Angular scope types. And this is still a bit of a work in progress, but basically it allows you to, on your directive definition object in Angular 1, you can specify scope types, and this works very similar to React prop types. And so you can get runtime type checking on your directives, which is something that like type checking your directives API is something that TypeScript just simply couldn't do. And so maybe with some of the Anyway, it's super cool, and I'm super excited about it. I've started using it here at work, and it helps people use my directives better. So, finally, my last pick is sort of tech-related, sort of not. It's a new podcast called Parent Programming by my buddy Kevin Lamping, and I'll share the Twitter handle so you can go look up the episodes and stuff. But just some people forget that family is really the most important thing ever for anything, and so. Parent programming kind of puts my 2 favorite things together, and so yeah, go check that out. Kara, what picks and tips do you have for us?
Just one pick this week. It's actually kind of early, but so CSSConf is coming up in a few weeks, and my friend Rachel, I think she was on the show 2 weeks ago, Rachel Moore, is doing a talk on ops tooling for UI. And I've seen some of the early drafts of it. It's going to be pretty cool, so I recommend checking that out when that comes out. That's my only pick.
Great. And now for our guests. You guys can fight over who goes first.
You want to go first?
Sure. So my pick is the ngconf demo that Jonathan made in ngconf a while back. We have updated it to use the latest TypeScript compiler, the latest Angular drop, and use system.js and the system module loader. So you just do not have to run the compiler. It runs in the browser as part of your development. You just write your TypeScript file in your favorite editor, and hit F5, and you get your code and errors and stuff.
Yeah, it's super cool to see the System.js stuff kind of go into place. So now you can kind of have a much smoother experience, much quicker experience to kind of get started. That's a great pick. So maybe the 2 picks that I would pick, one kind of dovetails to that. If you haven't seen Alex Eagle's Angular 2 video yet, which he does, I was just shocked. He does it in Visual Studio Code. Right after Visual Studio Code was released, he's like, oh, this is great. So he makes this video, walks you through the first 10 minutes of writing your first Angular 2 app, and how to get set up, and it's a good video to kind of get started. The other pick I would have, and kind of goes along with Jeff, I'm also going to be at Angular U. I'll be keynoting, I don't remember which day, but I'll be there. So definitely, if you are interested, if you're in the San Francisco area, come by, come check it out, and I'll be around for most of the days. So if you see me, grab me and have a conversation.
Great. Sounds good. Let me just quickly check our Q&A. Looks like it's empty, so I think I'll just wrap up the show. So again, just some general announcements. Next week's show is on Angular's new router with Brian Ford, who wrote the new router, so he knows a thing or two about it. And that's June 16th, same time, same place. So yeah, RSVP to the event, and it'll get added to your calendar in your time zone. So also, stickers are awesome, and Angular Air has them, so check out some links for that. And follow us on Twitter and Google+ for the latest and greatest from Angular Air. And so that's it. Thank you. Yeah, thanks to everybody for watching and for coming on. Really appreciate TypeScript guys coming here.
Yes.
So yeah, without any further ado, see you guys next week.
Bye.
Yeah.
Bye.